Hey everyone, welcome back to the channel. Today we're diving into Python's versatile lists, covering the basics, essential methods, iteration over a list, fun list games, and advanced topics like slicing, nesting, and modification. So let's get started. First, we discuss the topic lists. Lists are one of the most fundamental and versatile data structures in Python. They act as containers, grouping related items together, and they're mutable, meaning their size can grow or shrink, and their contents can change. Imagine you're creating a list in Python, like my list hello minus 4.2 and 5. In the first step, when you type this code, the interpreter creates a new list object denoted by the square brackets. Next, it processes each element individually, creating separate objects for the string hello, the float minus 4.2, and the integer 5. Finally, the variable mylist acts as a reference, holding links to these individual objects within the list. This means the list doesn't store the values directly, but instead keeps references to them, making it highly efficient and dynamic. In Python, list elements are accessed using zero based indexing, where the index represents the position of an element in the list. This program demonstrates the concept by using a list, oldest people, to store the ages of the top 5 oldest individuals sorted from oldest to youngest. The user inputs a number, and the program retrieves the corresponding age using list indexing. To enhance readability, the program dynamically appends the correct ordinal suffix, first, set second, third, etc., to the output, such as the third oldest person lived 117 years. This example showcases Python's flexibility in accessing list elements, handling indices, and formatting output dynamically for a user friendly experience. Lists in Python are versatile data structures that support a variety of operations, including creating lists, accessing elements, slicing, concatenation, and in place modification. This table illustrates several common operations with lists in Python, showcasing their versatility. Lists can be created using mylist, ts 1, 2, 3 to initialize with specified elements or list iter, to convert an iterable like a range or tuple into a list. Elements can be accessed via mylist index and slicing mylist start end extracts a subset, returning a new list. Concatenation mylist1 plus mylist2 combines two lists into a new one. Lists also support in place modification, such as updating an element or deleting an element, allowing for dynamic resizing. These operations highlight lists' ability to perform immutable like tasks alongside mutable in place changes, making them a cornerstone of Python programming. In Python, in place modification of a list using indexing allows you to change the value of an element directly within the list. The animation demonstrates this concept in two steps. In the first step, the list is modified in place by assigning a new value to a specific index, such as colors, yellow, which changes the second element of the list to yellow without creating a new list. In the second step, the example shows that simply assigning a variable to an element of an existing list. Instead, it only changes the value stored in the variable favcolor. This distinction highlights that in place modifications directly alter the contents of the list, while reassigning a variable doesn't affect the list itself, preserving the immutability of the list's elements in memory. This program demonstrates the concept of in place modification of a list by showing how changes to a list affect all references to that list. Initially, a list my teams is created with the elements raptors, heat, nets. Then, a new variable your teams is assigned the same list as my teams, creating a shared reference between the two variables. When the program modifies the second element of my teams by setting my teams Lakers, this change is applied directly to the list. Since both my teams and your teams point to the same list, the modification is reflected in both variables. The program then prints both lists. My team shows Raptors, Lakers, Nets, and your teams also shows Raptors, Lakers, Nets, illustrating how in place modifications affect all references to the list. This example highlights how mutable lists in Python allow changes that are shared among all variables, pointing to the same list object. This example demonstrates how to avoid unintended side effects of in place modification by creating a copy of a list. Initially, the list My Teams is created with the elements Raptors, Heat, Nets. To ensure changes to My Teams do not affect your teams, the variable Your Teams is assigned a copy of My Teams using slice notation, Your Teams, My Teams. This creates a new list object in memory for your teams, independent of the original list. When the second element of My Teams is modified to Lakers using My Teams, Lakers, the change is made directly to the original list. However, since your teams is a separate copy, its contents remain unchanged. The program then prints the two lists, showing that My Teams has been updated to Raptors, Lakers, Nets, while your teams retains its original values Raptors, Heat, Nets. This approach demonstrates how creating a copy of a list avoids unintentional modifications, preserving the integrity of the copied list. Now let's test your understanding. Let's see how well you can apply what you've learned about the list basics. I'll ask you a few questions, so think carefully before you answer. Here comes the first question. Imagine you have a list called My List and you want to delete the third element. Which of these statements gets the job done? Here comes another question for you. Which of the following operations doesn't modify a list directly, but instead creates a new one? Take a moment to review your answers and see how well they align with the concepts we've covered. Share in the comments how many you got right and how confident you feel about your understanding of the material. Next, move to the concept lists methods. List methods are powerful tools in Python that allow you to perform various operations on lists, such as adding or removing elements, sorting, reversing, and more. This table titled Adding Elements demonstrates the use of the append method in Python, which allows the addition of an element to the end of a list. It provides a consistent illustration across its rows to emphasize how this method functions. The append method is described as a straightforward operation where an item X is appended to the list's existing elements. For example, starting with mylist is equal to 5, 8 using the method mylist.append. 16 modifies the list in place, resulting in 5, 8, 16. This method is particularly useful for dynamically expanding lists during program execution. Each row in the table reiterates this process with the same method, description, and example to underline its simplicity and practical application in Python programming. This table titled Removing Elements explains three methods in Python used to remove elements from a list remove x, pop, and pop I. The remove x method eliminates the first occurrence of the value x from the list. For instance, starting with mylist equals to 5, 8, 14. Invoking mylist.remove 8 results in 5, 14. The pop method, on the other hand, removes and returns the last element of the list. For example, if mylist equals to 5, 8, 14, executing val is equal to mylist.pop will modify the list to 5, 8 and assign 14 to val. Lastly, the pop I method removes and returns the element at the specified index I. For instance, starting with mylist equals to 5, 8, 14, running val equals to mylist.pop0 modifies the list to 8, 14 and assigns 5 to val. These methods provide flexible options for manipulating and managing list contents effectively in Python programs. The table titled Miscellaneous introduces two useful list methods in Python indexX and countX. The indexX method returns the index of the first occurrence of the specified value x in the list. For example, with the list mylist equals to 5, 8, 14, calling mylist.index14 returns the index of the first occurrence of 14, which is 2. This method is helpful when you need to find the position of an element in a list. The countX method, on the other hand, counts how many times a particular value x appears in the list. For example, in the list mylist equals to 14, 5, 8, calling mylist.count of 5 returns 1 as the value 5 appears once in the list. These methods are particularly useful for searching and analyzing the contents of a list in Python, offering flexibility in handling list elements efficiently. This program demonstrates the concept of in place modification using list methods in Python. Initially, the list vals contains the elements 1, 4, 16. The first operation is vals.append 9, which adds the element 9 to the end of the list, modifying vals to 1, 4, 16, 9. The second operation, vals.insert 2, 18, inserts the element 18 at position 2, pushing the existing elements at that position and beyond to the right, resulting in the list 1, 4, 18, 16, 9. Next, vals.pop removes the last element of the list, which is 9, leaving the list as 1, 4, 18, 16. The subsequent operation vals.remove4 removes the first occurrence of the element 4, updating the list to 1, 18, 16. Finally, the statement vals.remove 55 attempts to remove the element 55. But since 55 is not present in the list, no changes are made, and the list remains 1, 18, 16. This example highlights how list methods like append, insert, pop, and remove modify the list in place, with the list reflecting the changes immediately after each operation. Now it's time to test your knowledge. Let's see how well you grasp the concepts of list methods. I'll present some questions, and you need to identify the output of the following programs. Think carefully and type your answers in the comment section for me to review. Here's a fun challenge for you. Take a look at this code. You have a list of temperatures and you add a new one at the end. But can you guess what happens when you try to access the last item in the list? What do you think will be printed? Take a moment to analyze. Here's another challenge for you. Take a look at this code. You have a list of actors and you want to insert a new one into the middle. What will the list look like after the insertion? What do you think the output will be? Give it a try and see if you can predict the order. Take a moment to reflect on your answer and compare it with the concepts we've discussed. Share in the comments whether your prediction was correct and how confident you feel about your understanding of the material. Next, move to the concept iterating over a list. Iteration over a list is a fundamental concept in programming that allows a programmer to access and process each element of a list one by one. This is particularly important because lists are commonly used to store collections of data. In Python, the process of iterating through a list is made simple with the for loop. The for loop is specifically designed for iterating over sequences, such as lists, making it one of the most essential tools in Python programming. A for loop allows a programmer to easily iterate through a list, performing operations like modifying values, checking conditions, or accumulating results. Mastering this skill is essential for efficient data manipulation in Python. This program demonstrates how to use a variable to track the largest even number while iterating over a list. Initially, the list nums contains the values 1, 4, 15, 456, and max even is set to none. The for loop begins by iterating over each number in the list. During each iteration, the program checks if the number is even using the condition num% 2 equals 0. If the number is even, it further checks whether max even is none, meaning no even number has been encountered yet, or if the current number is larger than max even. If either condition is true, max even is updated to the current number. Odd numbers and even numbers smaller than max even are ignored. Now that we've explored iterating over a list, it's time to test your understanding. Let's go through a few questions. Take your time to think them through and share your answers in the comments for me to review. Here comes the first question. Let's see if you can fill in the missing piece to count how many odd numbers are in the list. Here's another one for you. Can you fill in the missing part of the program to count how many negative numbers are in the list? Take a look and complete the code to make it work. Let's see if you can crack this one too. Assess your answer and see how it aligns with the concepts you've learned. Python provides several built-in functions that simplify the process of iterating over lists to find or calculate specific values. These functions serve as shortcuts for common operations, saving programmers from manually writing loops. For example, the all function returns true if every element in the list evaluates to true, non zero, or if the list is empty. In contrast, the any function returns true if any element in the list is true. When finding the largest or smallest value in a list, the max and min functions can be used respectively. Additionally, the sum function quickly calculates the sum of all elements in the list. These built in functions make list manipulation in Python more efficient and concise, allowing programmers to focus on higher level tasks without worrying about low level iteration logic. For instance, print all 1, 2, 3 will return true, and print sum negative 3, 5, 25 will return 27. These functions are essential tools for Python developers looking to streamline their list operations. Now that we've explored built in functions for iterating over lists, let's test your understanding with a few quick questions. Take your time, think through your answers, and share them in the comments for me to review. Here's a quick question for you. Given the list, can you figure out what value will be returned by the sum function? Here's another question for you. With the same list, what do you think will be returned by the max function? Think you've got it? Here's the last question for you. With what do you think will be returned by the any function? Give it your best guess. Take a moment to review your answers and see how closely they align with the concepts we've covered. Let me know in the comments how many you got right and how confident you feel about your understanding. Let's dive into the concept of list games. Lists are an essential part of Python, and mastering them through fun activities can significantly enhance programming skills. The activities are designed to help programmers get comfortable with iterating through lists, exploring concepts such as finding the maximum value, checking conditions, or applying operations effectively. This example illustrates the process of finding the maximum value in a list. Starting with an initial value, each element in the array 69, 24, 28, 22, 99, 57, 98 is compared to the current maximum. If a larger value is encountered, the maximum is updated or stored. In this case, as the loop progresses, the maximum value is identified as 99. This activity reinforces understanding of iterative comparisons, helping users develop efficiency and precision in their approach. Counting negative values in a list involves iterating through each element and incrementing a counter whenever a negative number is encountered. For example, in the given array, 14 minus 38 minus 1, 77, 9 minus 46 minus 71, we start with a counter initialized to 0. As we move through the list, each negative number minus 38, minus 1, minus 46, and minus 71 triggers an increment in the counter. By the end of the iteration, the counter reflects the total number of negative values in the list, which is 4. This exercise emphasizes the importance of conditions and iteration in list processing, while also serving as a fun and interactive way to practice logic and programming skills. Manually sorting the largest value in a list involves an iterative process where the largest number is moved step by step to the rightmost position in the array. This process mimics the logic behind the bubble sort algorithm. Starting with the first two elements, the algorithm compares them and swaps their positions if the left element is greater than the right one. This process is repeated across the list until the largest value bubbles up to the last position. Repeating this operation ensures that the largest value is correctly placed at the end of the array. This exercise helps grasp sorting mechanics by demonstrating how comparisons and swaps organize list values, encouraging efficiency in achieving the goal quickly. Let's take a closer look at the concept list slicing. List slicing is a powerful feature in Python that allows a programmer to extract a subset of elements from a list using a specific range. The slice notation is used to specify the start and end positions of the range, creating a new list that contains the desired elements. To illustrate list slicing, let's walk through an example. First, a list object, my list, is created with the elements practicing with list slicing. In the second step, the list is sliced from index 0 to index 3, yielding the first three elements of the list and then printed out. The third step demonstrates slicing from index 1 to index 2, which results in a new list containing only the second element, with. This example highlights how list slicing helps programmers access precise parts of a list efficiently. Now that we've explored list slicing, let's test your understanding with a few quick questions. Take a moment to consider the questions and write down your answers in the comments for me to review. Here's your first challenge. Take a look at the list and try to figure out what happens when we slice it from index 1 to index 5. Ready to put your skills to the test? Share your answer in the comments below. Time for your second challenge. What do you think the result will be when we slice the list from index 5 to index 10? Give it a go and drop your answer in the comments. Here's your third challenge. What do you think the result will be when we slice the list from index 3 to the second to last element? Share your thoughts in the comments. Take a few moments to review your answers thoughtfully, step by step. Consider what you've grasped so far and share in the comments how many answers you got correct and how confident you are in your understanding of the material. The table of common list slicing operations demonstrates various ways to manipulate and access specific elements within a list in Python. The start colon end operation retrieves a subset of the list from the index start up to, but not including, the index end. For example, given my list equals to 5, 10, 20, print my list 0 colon 2 returns 5, 10. The start colon end colon stride operation slices the list from start to end and includes every stride element in between, as shown by print my list 0 colon 5 colon 3, which returns 540 from my list equals to 5, 10, 20, 40, 80. The start colon operation retrieves the list from the start index to the end of the list, like print my list 2 colon, which gives 20, 40, 80. The colon end operation slices the list from the beginning up to, but not including, the end index, with print mylist colon 4 returning 5, 10, 20, 40. Finally, the brackets colon operation creates a copy of the entire list, as shown in print mylist colon, which returns 5, 10, 20, 40, 80. These slicing techniques are crucial for efficiently accessing and manipulating parts of a list in Python. Now, let's put your skills to the test. Let's see how well you can apply what you've learned about list slicing operations. I'll ask a few questions, so take a moment to think carefully before you answer and type your answer in the comments. Ready? Here's the challenge for you. Test your understanding of list slicing with the expressions below. Match each slicing expression on the left to the correct resulting list on the right. This is a great way to solidify your slicing skills. Take your time and let's see how many you get right. Take a moment to review your answer, compare it with what you've learned, and share in the comments if you got it right and how confident you feel about your understanding. Here's another challenge for you. What will be the output of the slice list given the following code? Take a guess and see if you can figure it out. Let's test your slicing skills. Take a moment to reflect on your response. Compare it with the concepts you've learned so far, and let us know if your answer matches. How confident are you in your understanding of list slicing? Feel free to share your thoughts in the comments. Next, we explore the concept list nesting. In Python, lists are versatile structures that can hold any type of object as an element, including other lists. This powerful feature allows the creation of multidimensional lists that are useful for managing complex data structures. In the given example, a multidimensional list is created to demonstrate the concept of list nesting. The list, my list, contains two nested lists, 10, 20, and 30, 40. The first nested list, 10, 20, is accessed and displayed as part of the output. Similarly, the second nested list, 30, 40, is retrieved and printed. Additionally, the example illustrates how to access specific elements within a nested list by indexing further into it. For instance, the first element of the first nested list, 10, is accessed and displayed. Then the second element is accessed and displayed. This example effectively highlights how nested lists enable the organization and retrieval of multidimensional data in Python. In this example, the concept of list nesting is demonstrated using a multidimensional list called mylist, which contains three nested lists A, B, C, D, and E, F. In the first step, each nested list can be accessed directly using a single indexing operation. For example, accessing mylist 0 retrieves the first nested list, A, B. Similarly, mylist 1 retrieves the second nested list, C, D, and so on. In the second step, the individual elements within the nested lists can be accessed using two levels of indexing. For instance, first mylist retrieves the first element of the first nested list, while the second mylist retrieves the second element of the second nested list. This example illustrates the concept of a two-dimensional list, where a list contains other lists as its elements, forming a table-like structure. In the first step, a new list object, myList, is created with two nested lists, 10, 0, 55, and 0, 4, 16. Each nested list represents a row in the two-dimensional structure. Elements within this structure can be accessed using two indices, row, column. For instance, myList refers to the first element of the first row, which is 10, and myList refers to the third element of the second row, which is 16. In the second step, elements in the two-dimensional list are modified. The value at mylist is updated to 33, replacing the original 10. Similarly, the value at mylist is updated to 77 and mylist is updated to 99. This example demonstrates how two-dimensional lists allow both access and modification of specific elements by specifying their row and column indices. This example demonstrates how to iterate over multidimensional lists, which is a common operation when working with nested data structures like tables. In this scenario, a programmer uses nested for loops to access all the elements of a 3 by 3 table represented by a list of lists. Each inner list corresponds to a row in the table, containing numerical values for different currencies. In the first step of the process, the outer for loop iterates over the rows of the table, assigning each list, representing a row, to the variable row. The inner for loop then iterates over the elements of each row, the individual columns. During each iteration of the inner loop, the value of the current cell is printed, with a tab-like spacing provided by end equals space. After all the columns of a row have been printed, a new line is started using the print statement. This approach allows the entire table to be displayed row by row, making it an effective way to iterate through and display elements of multidimensional lists. Now that we've covered the concept of list nesting, it's time to put your knowledge to the test. Think carefully about each question, keeping the key concept in mind. Drop your answers in the comments, and I'll check them out. Here's your first challenge. Given the list nums equals to 10, 20, 30, and 98, 99, what do you think nums 00 evaluates to? Dive into those nested lists and uncover the answer. Let's see how sharp your list indexing skills are. Share your thoughts below. Here's your second challenge. Given the list nums equals to 10, 20, 30, and 98, 99, can you figure out what nums 11 evaluates to? Take a close look at the second nested list and its elements. What value do you uncover? Drop your answer below and show off your skills. Check your answer carefully and see how it matches the concept you've studied. Share in the comments if it's correct and how confident you feel about your understanding. Next, we explore another concept of list modification. List modification in Python refers to the ability to change, add, or remove elements from a list after it has been created. Since lists are mutable, meaning their contents can be altered, Python provides various methods to modify them efficiently. When modifying a list during iteration in Python, care must be taken to avoid unintended behavior, such as skipping elements or causing errors. For example, consider two lists, nums1 equals to 5, 10, 15, and nums2 equals to 10, 15, and the task of removing elements from nums1 that are also present in nums2. If we directly modify nums1 while iterating over it, the iteration will skip elements after a removal. This happens because when an element is removed, the subsequent elements shift, which causes the loop to move to the next index, potentially skipping an element. To prevent this, a common solution is to iterate over a copy of nums1 instead of the original list. By doing so, the loop operates on a static version of the list while allowing changes to be applied to the original list. For instance, using nums1 square brackets colon creates a shallow copy of nums1, and iterating over this copy ensures that all modifications are performed correctly. This approach guarantees that the list modification is effective and no elements are skipped during the process, demonstrating a safe and effective way to handle list modifications in Python. In conclusion, we have successfully explored the fundamental concepts of Python lists, from understanding list slicing and modifications to mastering nested and multidimensional lists. You've gained a strong foundation in handling one of Python's most versatile data structures. These concepts are essential for solving real world problems, working with data, and building efficient programs. By learning how to slice lists, modify them, and iterate through nested structures, you've equipped yourself with tools that are both powerful and practical. Keep experimenting with these techniques, challenging yourself with new problems, and building on this knowledge as you explore more advanced Python concepts. If you enjoyed this tutorial, please like, comment, and subscribe to our channel. Thanks for watching.